This video will help you with solving compound inequalities, but first let's review. Yesterday we learned that there are two types. We have and compound inequalities. We also have or compound inequalities. And compound inequalities. Our example yesterday was the temperatures between 56 and 73 degrees. If I were to graph this situation, it would look something like this. So I plot 56 and 73, and I'm going to use open circles at both because it just says between. It doesn't say is or at least 56 or 73. It says between. So any value that is in between 56 and 73 will make this situation true. So our graph ends up looking something like this. Or compound inequalities. Our example yesterday was discounts for children under 13 or adults 65 and over. If I were to graph this situation, it would look something like this. I would plot 13 and then 65. So at 13, I would use an open circle because it says children under 13, so it does not include anyone who is 13, so under 13. It also says adults 65 and over, so I would use a closed circle because it includes adults who are 65 and also adults who are over 65. So I would use a closed circle. So my graph would end up looking something like this. So how to solve compound inequalities when there are actual numbers? So first we have to use our knowledge of solving one-step, two-step, and sometimes multi-step inequalities. First we have to distribute if necessary, then we combine like terms if necessary. Then our goal is to isolate the variable using inverse operations. So let's do an example together of how to solve and compound inequalities. So first, if I look at my compound inequality, I'm used to seeing just an inequality with two sides, but here there are actually three sides or three parts, so I'll refer to them as parts. So the first thing I want to do is distribute because I see these parentheses. So I know that 2 times x is 2x, and then 2 times this minus 1 is negative 2, but I would write it as minus 2, so 2x minus 2, and then I'll bring down the rest of my compound inequality. So again, I still want to get the x by itself, so I have to add 2 because that's the inverse of subtracting 2. So I'm going to add 2 to all three parts. Negative 4 plus 2 I know is negative 2, and I'll bring down my inequality symbol. These cancel out, so I'm left with 2x, bring down my inequality symbol. 6 plus 2 I know is 8. So again, I still want to get the x by itself, so I'll divide all three parts by 2. Negative 2 divided by 2 I know is negative 1, bring down my inequality symbol. These 2's cancel out, so I have x is less than or equal to 4. So my inequality is negative 1 is less than or equal to x and less than or equal to 4. So when I graph this, my solution is going to look something like this. At negative 1, I'll use my closed circle because of this inequality symbol. At 4, I'll use my closed circle because of this inequality symbol. So any value in between negative 1 and 4, when I plug it into my original compound inequality, will make the inequality true. So if I were to write my solution using set notation, it would be x such that negative 1 is less than or equal to x and less than or equal to 4. If I were to use or write my solution using interval notation, I know I have to be between the values 1 and 4. So I'll start by writing that. And then I see that there are closed circles, so I'm going to use brackets for both. How to solve or compound inequalities. So I'm going to solve each of these inequalities separately because they're or compound inequalities. So I'll do it one by one. So if I start over here, I'm going to distribute the 4 to the m and to the 3. 4 times m is 4m, 4 times 3 is 12, so plus 12, bring down my inequality symbol. And I have a two-step inequality. So I'll subtract 12 from both sides. So I'm left with 4m is less than 8, and I'll divide both sides by 4, so I get m is less than 2, bring down the word or, and then now I'm going to solve this side, or that inequality. So I'll subtract 7 from both sides. So negative 2m is less than negative 6. And I'll divide both sides by negative 2. So I have m, and then I'll flip my inequality symbol, so m is greater than 3. So these are my two solutions. So when I graph them on a number line, my solution set is going to look something like this. So I have m is less than 2. So I'll use an open circle because of this inequality symbol, so less than 2. And then I also have m is greater than 3, so I'll use an open circle because of this inequality symbol, so greater than 3. So when I plug in a value that's less than 2, it'll make this inequality true. When I plug in a value that's greater than 3, it'll make this inequality true. So when I write my solution using set notation, it will be m such that m is less than 2 or m is greater than 3. And when I write my solution using interval notation, I'm just going to write it one by one. So this one first, I know that I can go from negative infinity, well, that looks funny, negative infinity all the way up to 2, and then with anytime I use infinity, or negative infinity and infinity, I'm going to use parentheses, and then since I see this inequality symbol, I'll use parentheses. Or, and then I'm just going to write my interval notation for this inequality. So I know I can go from 3 all the way up to infinity because it says, because it says any number m is greater than 3. So again, I'll use parentheses, and then I'll also use parentheses here for 3 because of this inequality symbol. So here are 3 practice problems for solving and compound inequalities. So complete these in your notebooks. You can pause the video, then unpause when you're done, and we'll work through numbers 1 through 3 together to see if you're correct. So let's see how you did with number 1. First, I want to distribute the 3 because I see these parentheses. So I know that 3 times x is 3x, and then 3 times 2 is 6, so plus 6. Then I'm going to bring down the rest of my inequality, my compound inequality. And then the next thing I want to do is get rid of this plus 6, because again I want to get the x by itself. So I'm going to subtract 6 from all 3 parts. On my left side, I know that negative 3 minus 6 is negative 9. Bring down my inequality symbol. And then I just have 3x remaining in the middle, and then I'll bring down my inequality symbol. And then I have 6. So then again, the next thing I want to do is still get x by itself. So I'm going to divide all 3 parts by 3, because that's my coefficient. Negative 9 divided by 3 is negative 3. Bring down my inequality symbol. These cancel out, so I have x is less than or equal to 2. So my solution is negative 3 is less than or equal to x and less than or equal to 2. So if I graph my solution, it'll look something like this. I have negative 3 and then I have 2. So at negative 3 I'm going to use closed circle. At 2 I'm going to use also a closed circle. So all my solutions are in between negative 3 and 2. So that's what your graph should look like. So if I show my solution using set notation, it's going to be x such that negative 3 is less than or equal to x is less than or equal to 2. And then if I use interval notation, I know my values are going to be in between 3 and then 2. If I look over here, I'm going to use brackets because I see closed circles. So let's see how you did with number 2. First, I want to subtract 1 from all 3 parts because that's my constant. 7 minus 1 is 6. Bring down my inequality symbol. I'm left with just 3n in the middle. So then I just realized I wrote this incorrectly. So let's start again. So this should actually be going this way. Now let's solve it. So I'm going to subtract 1 from all 3 parts. So 6 is less than or equal to 3n is less than 12. And then I want to divide by my coefficient, all 3 parts. So I divide all 3 parts by 3. So I get 2 is less than or equal to n, because these cancel out, is less than 4. So then if I graph my solution, it's going to look something like this. I have 2 and 4. So I'm going to have a closed circle at 2, open circle at 4. So any value in between 2 and 4 will make this inequality true, that compound inequality true. And then if I write it using set notation, it's n such that 2 is less than or equal to n and less than 4. And then if I use my interval notation, I know that I have to pick values between 2 and 4. And then so here at the 2 I see a closed circle, so I'm going to use a bracket. And then here at the 4 I see an open circle, so I'm going to use a parentheses. And then let's see how you did with the last one. Here I don't have a constant, so I do have my coefficient, so I can just divide all 3 parts by my coefficient. So negative 6 divided by 3 I know is negative 2. Bring down my inequality symbol. These cancel out, so I have x, and then 15 divided by 3 is 5. So when I graph my solution, I'm going to have negative 2 and then 5, so I'll have a closed circle at negative 2, and then I'll have an open circle at 5, and then any value in between will make my compound inequality true when I plug it in. And then when I write my set notation, it's x such that negative 2 is less than or equal to x and less than 5. And then when I write my interval notation, I know I have to be between the values of negative 2 and 5. When I look over here, a closed circle means I'm going to use brackets, and an open circle means I'm going to use parentheses.